I would like to thank Xenia and Dennis for the opportunity to share the experience with Apache community. Thanks to Gridgame and the contributors of Apache Ignite. And also, I would like to thank our contributors in Banco do Brasil, in the Horus project, for the work you have been doing. They have been instrumental for making this a reality. You have made the Horus digital service in the market platform real, and I'm really proud of this work we have been doing together. Okay, thank you guys. Thank you. Well, to organize our presentation, we'll follow this agenda. We'll talk about the business problem that we are trying to solve. What solution we're designing to solve that problem. We'll talk a little about the main concepts of the event-driven architecture and complex event processing, which support the solution we design. The strategies we use to implement the CAP solution. This strategy is it's a good way to see how we are using Apache Ignite and Drools. We have some demos like events loaded and balanced in distribution of the events. A demo for performance and capacity. A little demo about continuous integration and continuous delivery for microservices. We'll show you our microservices dashboards in production environment and try to show how many microservices are running using this architecture and platform. And finally, the next challenge for the near future. Okay, about 12 years ago, all the banks have been dealing with digital transformation growing in volumes of customers and transactions, and also the number of changes. In the past, Banco do Brasil tried to use a mix of solutions, but these solutions could not deal with the high volume of customers and did not implement Omni China concepts. Although those solutions implemented a multi-channel approach, they didn't have a good user experience. The requirement was to monitoring and serve more than 22 million of digital customers access along a month. So, few years ago, about 4 years ago, Banco do Brasil had decided to self-implement a new omni-channel platform and give it the name Horus. Like the mythological god, the omni-channel digital service platform has the responsibility to know all the customers' needs and help them to solve the problems. Today, we have implemented in production a lot of features for digital service and digital marketing on this platform. For now, let me invite Nate to show you what are the concepts that support these solutions. You select. Please, Nate.
Thank you, Manoel. I'll share my screen. Can you see my screen?
It's okay to me.
Okay, very good. So, hello everyone. Thank you all for joining us in this meetup. I'm glad to be here to share our experience. I would like to show the architecture vision of the system that we are going to present, okay? We have combined two powerful system paradigms to implement our solution. The paradigms are EDA and CEP. EDA stands for Event-Oriented Architecture, and it is an architecture pattern. CEP stands for Complex Event Processing, and it is a process pattern. With the whole structure formed from this association, we were able to obtain a scalable, resilient, and extremely efficient environment. I'd like to present some concepts related to those paradigms. Our entire infrastructure and set of applications are event-driven, okay? Event for our system is a record of a significant change of state in the application domain at a given point in the time. For the event infrastructure, event-driven infrastructure, we used the most complex set of components available. We are using producers here. We have also consumers, the middleware, that is the broker, and we used also a combination of several patterns. For the event process engine, we used some of common processing pattern demanded for our business strategy. And finally, we also used the microservice architecture style to structure our services. Let's look more closely the usage strategy of these paradigms in our solution. Here, we have a diagram that represents the tiers of processing used to structure our entire solution. All these event communication here are propagated in asynchronous mode using publish-subscribe pattern. This pattern allows multiple consumers to subscribe and receive events. The publishing and subscriptions are executed by using topics, which represents the event's destinies. I'll try to show you how we implemented the combination of event-driven and event processing to support our solution. Each one of these tiers here can be related to an event-driven components in our system. In the client processing tier here, we see probes, agents, and interfaces that plays the role of producers. In the interface processing tier, we see the MQTT proxy, which adapts the pub/sub events between the client processing tier and message processing tier. In the message processing tier, we see the interaction event bus, which plays the roles of event broker. It's our middleware. This event broker receive and transfer the events to the destination, which are the microservices subscribed in topics to receive the message, those microservices. In these business processing tiers, we have the microservices which plays the role of consumers, but also can act as producers when they publish some events to the bus. Summarizing, we have producers here, we have consumers, we have the middleware, that is the broker associated with the MQTT proxies, and finally, the persistence cache tier, which is used to store and recover data to use it in the system, according to the necessity of the microservice, okay? Regards the event processing paradigm, there are some fundamental CP design patterns that can be thought as building blocks, and they can be combined to create more complex solutions. Here, I have picked up a few of those fundamental patterns to give an idea of our processing solution. We have combined them in a different ways to implement our business strategy, okay? The primary goal of this event engine is detecting, selecting, and the interesting events from an event cloud, finding their relationships, and inferring new data from them. Broadly speaking, we can have different sources of events. The events can be incoming to the service from the event bus, in our case, orders interaction bus, or loading from a database, according to the match of the rules in the CP engine, will be generated new events, which can be seen as simple match of events until complex aggregations, enrichments, and new complex events can be created from those incoming events. Summarizing, here we have only a taste of the power of these patterns. In our solutions, we have used all these patterns and a lot of others according to the business requirements, okay? Now, we'll return the word to Manoel so he can show you the strategy used to implement our solution and the most exciting part, the show me the code. Manoel, please.
Thank you, Omni. Let's start again. Well, after a lot of components evaluation along the time, we decided to use this mix of powerful technologies to implement the Horus platform. Let's take a look at what we did. We use almost all the Apache Ignite core capabilities as a service grid to provide resilience for all the microservices and to provide dynamic service lifecycle, as a computing grid for collocated processing according to the service requirements, as an in-memory data grid and an in-memory database according to the service requirements too. We use cache affinity to distribute events for event bus to microservice instances and to the Drools working memories. In some cases, we use memory data store or persistent store using a mix of data layers, like Ignite persistence, relational database, or NoSQL persistence as well. From the Drools frameworks, we use only the business rules engine, called the Drools Expert, and the complex event processing features, called the Drools Fusion. Horus is the code name of the Omni China digital service and the marketing platform for Banco do Brasil, and the code name of the CEP ecosystem. We have implemented in-house the core frameworks and the transports and persistence integrations. Also, we use HA proxy as a high-performance load balancer for TCP, HTTP, and the WebSockets balancing. We use the Mockety. Mockety is a MQTT broker open source project we use to implement the Horus MQTT proxy. The interaction event bus, as they said, is based on subscriber broker called typical rendezvous and is supported by the vendor. Well, our rule service implementation integrates Apache Ignite. This rule service implementation integrates Apache Ignite ecosystem and the Drools and the components of the Horus. A unique implementation runs and controls all the CEP microservices inside this platform. The Horus microservices is a Drools Maven archetype project. So you can use Eclipse or any EDI, to develop the microservice. And the Drools rules language is used to describe the events, correlation, filters, and so on. We could use the Java resource in this project as well, all the resource of Java. Ignite is the all-service execution platform and support the most advanced features for microservice resilience. We can run many microservices in the same Ignite cluster, but in general, we run on Horus CEP microservice per cluster inside our platform. Okay, let's show you some examples to demonstrate how this works in the real. In this demo, we are using the same architecture as in production, but in a thin scale, okay? As you can see, the MQTT client will act as a probe or agent. In production, we have many web or Angular or React applications, including mobile, acting as a probe agents or interfaces. In both cases, the client application sends and receives events to and from the event bus using MQTT proxy and event bus based on daemon based on rendezvous daemon. In these demos, we use two Ignite nodes to build a cluster and running one meetup microservice instance per node, okay? And we have only in-memory data regions for caches. It's very hard to see all the events components working in real time. So we make this animation to illustrate how events load balancing distribution happens. Let's start here. Using an MQTT client, I will publish the first ping event with a counter field starting 0 and a max 100 ping pong hits. The event bus sends this ping event to both subscribers. The orders transport check Ignite cache affinity to select which microservice instance is responsible for that event and which working memory will process the Drools rules in this case. The rule process the ping event and produce a pong event, incrementing the count field by 1. Again, the event bus sends the pong event to all subscribers, and again, the transports need to check the cache affinity to select which microservice instance and the working memory will process the event. The rule processes the pong event, incremented the field count, and send another ping event back. And again, and again, and again. This will happen many times until the last event pinger or pong increments the field count to maximum value. In this time, the last event producer will be the winner of the ping pong game. Send the last information about the ping pong winner. Well, let's show how this happens when running in a real-time demo, okay? I will change to MQTT client now. I'm connected into MQTT proxy using this. And I will publish the first ping event, select the maximum value to 100. So ping pong will reach until this maximum. Okay. I sent the event. As you can see, the last event indicates the winner. In this case, the ping was the winner in this demo. As you can see, the working memory ID is changed along the execution. As you can see, we have in this case 3 working memories in each instance of the microservice. As you can see, the node ID has changed too. So many of the events are dealt by the working memories in each instance of the microservices along this happen. Okay. We cannot decide in advance using this approach which working memory Ignite node will process the event. It depends on the affinity partition balance because we use the Apache Ignite cache affinity to select that instance and working memory. Okay. Well, let's see another demo. Okay. Let's try to show how great is the performance and capacity of this solution. In my machine, I have a limited of processing capacity. I have only 8 virtual cores in my machine. Now, I need to limit CPU usage to reduce to a single mode, okay? I will turn off the second node of Apache Ignite, start, and let's show the animation to demonstrate that visually. To start, I sent start event, selecting the maximum unique users will simulate accessing and sending events, okay? In this case, after send event, using 2 threads only, this mesh steps will generate 1 million of events to simulate 1 million of unique users. Each unique user will be processed by only one working memory thread due to the affinity transport or the affinity cache. During the execution, the Microsoft sends the info events. These info events shows the performance to send and to process those events. The Microsoft uses two Ignite atomic long caches as counters to check how many events are sent and processed inside the cluster. Okay. Well, let's show these wrappings running a real-time demo. And here I'm using again the MQTT client. Okay. I will send now the start event, this mesh start event, select 1 million of unique users using 2 threads, okay? My machine may be freeze, so I hope this do not happen. Let's try. Okay. It's running. That's my machine consume. 100% of processing. I hope you are listening now.
We are
Let's
listening,
take a
Manoel.
look into. Okay, thank you, Silvio. Thank you, Silvio. Thank you. Let's take a look in the info events. We are running about half the precursors. We are running at speed, sending about 13,000 of events per second, and processing that events at about the same speed as well. Let's wait a few seconds. Wait to finish. Be patient, please. Almost there. Okay, well done. In this case, this mesh processing has finished. My CPU returned the normal processing consumed. Okay. In my case, all the 1 million events of unique users was sent in a speed and processed in the same speed of 13,000 events per second. Okay. Well, now let's talk a little about the continuous integration. CI/CD pipeline was integrated to reduce the downtime in a so complex ecosystem. Okay. The continuous integration is the same you have been using to build your Java apps on Java applications. Use any kind of EDI, okay? You use a Git repo. After commits, the application lifecycle management switch starts an event Maven pipeline to compile the packages, make some validations as well. and to manage the project dependencies. After successful build, Maven published the artifacts in the Maven remote Maven repo. Okay. So the continuous delivery process could get the artifacts in this remote repo. So the continuous delivery is a little different from the other orchestrators. In this case, in our case, the RS core coordinates the Drools and the Maven integration to get new artifacts from the remote repo. It occurs online in a real-time fashion. Okay. Uh, in this integration with Drools and Maven, the artifacts are loaded locally, are maintained locally in the Maven repo. If the repo have a new version for the microservice, or score freeze the transports. All the transports are freezed. The working memories processing for that microservice are freezed too, and the rules processing updates the microservice independence. Okay. After that, WarScore insert a new event of the type the type service release update, and our working memories are activated, and the release processes restarted. Okay. So the microservice turns immediately process all the rules. No JVM, no Java stop, no Ignite clusters restarted are required in this scenario. The microservice is updated in real-time fashion. Let's take a look at how it's work in demo. In this case, I will simulate a continuous integration with a local Maven build. Okay, let's change. Sorry, I don't have an animation for this scenario, but let's take a look for this scenario. Okay. Okay. As you can see, in this case, I just subscribe an event from the microservice. This info are sending many information about the microservice running now. This is the service version for this moment, 1.0.1. Okay. To simulate the continuous integration, I use the Apache Maven and my Eclipse project. I will change now the version for another value, for example, 2. And I will build again the project using Maven build. Just a second, please. A little bit more. Okay, just fast. In this case, the local Maven process updates the local repo. Okay, let's take a look here. In this case, we configure the process to update the environment, to update the Maven repo after 5 seconds or each 5 seconds. In this case, the microservice was updated with a new version, and here in the MQTT client, we can see the new event with a new version. Well, this happens. We use this in productions a lot of time. Okay. And now, Nate, could you please show the service in production environment?
Thanks, Manoel. I'll be sharing my screen. Okay. I'm accessing the production page in this moment, okay? This is our production page. This is actually our administration portal called Ors Admin. Through this window, we can access the real-time behavior of the implemented microservices. Ors Admin is a monitoring and support dashboard for the Ors platform. There are 4 panels on the top showing business information. The leftmost panel shows the number of users connected to the platform at this very moment. The second panel, to the left here, shows the number of operators connected, who are probably performing the customer service to those connected users. The next panel on the right shows the number of users waiting for customer services on Banco do Brasil private channels at this moment. And the next and the rightmost panel also shows the number of users waiting for the service customer. However, those users are accessing via social media. That is, for example, WhatsApp, Facebook, etc. Just below, in the center of the page, we have a larger panel containing all the microservices implemented on the Ors platform. Up to this moment, we can count 31 microservices, each one acting cooperatively to execute digital service and digital marketing. And at the bottom panel here, we have the real-time variation in the number of users being served by the Ors platform at this very moment. This panel is updated every 7 seconds. Very good, incredible. So I will return to the presentation now. And I'd like to show some interfaces used to access the attendance environment of the Ors platform. In this image, we have some sample of the platform interfaces for the service operators and managers. We can see here several functionalities used by the operators to serve the customers. And here we have example of profiles, okay, profiles of users, also filters, service cells, and more. All these interfaces produce and consumes events to communicate with the Ors microservices. Okay. Now in this image, I have also some sample of interface, but now of the client interface used by the customers. We can see here chat screen used in 2 types of devices: web page, generally from desktop computers, and app pages from mobile devices. These interfaces are also event-driven, producing and consuming events to interact with the microservices, Ors microservices. Both of the screens can be used by the customers to communicate with the bank. And this communication can be started by one of 2 sides, by the customer or by the bank. Customer can intentionally want to start a chat with the bank by clicking on the button available for this, or through the app. On the other hand, the operator can offer some help or do some marketing approach through the same chat, provoking the client to accept and start a new communication. As you can see here, we have also the public area of Banco do Brasil internet portal. This page is used to serve all kinds of public, customers and non-customers. The chat can be accessed by clicking the button on bottom right corner, and the link will be made available at the end of the meetup. It's a good opportunity to see how our virtual assistant answer some questions using the full range of microservices implemented on the Horus platform. And finally, the next chance. For the next 2 years, we expect to implement this roadmap. We intend to use Apache Ignite machine learning to seamlessly support the virtual assistant capabilities like voice streaming, voice over IP, video conference, sentiment analysis, and more. We also expect using Apache Ignite resilience to implement core banking applications, and we'll try to move the Horus infrastructure to our private cloud based on Kubernetes containers. Okay, thank you so much for your time and your attention. That's it. Manoel?
Thank you
And
for
we
your
have
time.
some questions in the chat. So can you Drools rules be loaded dynamically, or you need to recompile the application?
Yeah, it's a very good question. Thank you, Christian. Indeed, for the most microservices, we use this continuous integrations build process, as I showed you. We have in the digital marketing capabilities in Horus implemented by microservices Jarvis, which creates Drools rules files in real time and makes all CI/CD pipelines in a real-time fashion. So we use both of this approach to solve that. Okay.
I hope that was a very complete answer. So, and we have now one. Where do rules execute inside Ignite?
Yes. We use Apache Ignite service capability. Our Horus rules service implementation is Apache Ignite service. And running inside the clusters of the Apache Ignite together in all the other capabilities of the Ignite in the clusters.
And now one question in the chat. Input stream and enhance stream. Do we go to the same event channel? And are you using...
I don't know if I understand the question, but I will try to explain. We have a transport framework implemented by Horus, which try to make seamless to the developer of the microservices to deal with the events. So we have stream processing integrated using this transport, request response, async request response transport integrated as well. Transactions we have in a house, one implementation of integration architecture. So many transports could be implemented. So the implementation of the core of the microservices are the same. All the microservices use this approach. So we use streams or message brokers or request response. All the microservices is the same. They deal with events, so complex events as well.
And now question, are you using Ignite service for your services?
As I said, we use Apache Ignite to implement all the services using all the resiliency capabilities of Apache Ignite, and we implement the one integration service as well. So when we develop the microservice, the CEP microservice, this CEP don't know it will running inside the Apache Ignite. So we have a layer which is responsible to integrate Drools microservices, Drools capabilities, Apache Ignite, and transports and persistence, and it's like a facade. Your microservice is built only using a Drools Maven archetype project. So you can use many of capabilities of Drools. You can use many of capabilities of Apache Ignite. You can use many of transports implemented by this framework, Horus. All the same, in this runs inside of Apache Ignite cluster, okay?
What is the size of your production cluster? It runs on bare metal or containers?
Both. Well, let me to rephrase. We use the most important and the most I think it's the most important microservices, and which needs high performance environment. We runs in bare metals, okay? Some microservices are running in the virtual machines, running, we use VMware to implement our ecosystems of virtual machines, okay? And running in Kubernetes, it's very difficult to implement a high performance inside of our infrastructure. Our infrastructure is very limited in capabilities. We have hardware and environments very old, very difficult to perform using some kind of little bit thinning containers, okay? So as we use Apache Ignite to run the microservices, we can get the most important requirements attended. So resilience is guaranteed, the performance start to stop the microservices is guaranteed, and restarts only by the clusters without restart all the environment. You can start to stop, restart, update the microservices in the real time. It's very, very important. Kubernetes containers don't have this approach, don't have the same approach. I think we can take a new 12 factors to implement microservices inside this architecture, okay? I wrote some article about that because some 3 or 4 factors of 12 factors to implement microservices in containers, it's not very very good to implement CEP microservices or EDA applications, okay?
And maybe that's part of this, the same question. How do you scale your Ignite cluster?
We have a different approach. We estimate the infrastructure, and when we have a high volume that we cannot support with this infrastructure, we don't get new machines, we don't get new environment. We try to figure it out, the microservices, and turn the microservices, implement, change the strategy so you can make it a lot or more event process using the same infrastructure, okay? It's not like, let me try to extend the containers instance like Kubernetes makes. We use about the the most important microservices. For example, we use two bare metals with 10 nodes in each bare metals. So in the cluster, we have 20 nodes running the cluster for one microservice. This microservice is the responsible for monitoring all events coming from the users in the channels, correlates these events with all the data about that users, like these users click on the give menu option in the application. So who is the users who clicked on this link? What is name and what is this many attributes? So it's the biggest microservice. We have only two bare metals. Okay. We don't need to expand this. Okay, thank you, Sandy.
So I'll continue with the questions from the chat. Is Ignite used as the working memory?
We have a lot of questions.
Yeah, we have a lot.
Sorry.
So I'll continue just for people who are listening to the video after. So they cannot read the chat because they will watch the video. So I'll just read them. So is Ignite used as working memory for Drools?
I don't see the.
That's up.
Where is the question?
That's like 10 minutes ago.
Omni China, Canada Drools,
yeah, is Ignite used as a working
production?
That's before.
Okay, no, it's not the approach we implement. Is Ignite used as the working memory of Drools? No, we have a framework responsible to integrate working memories of Drools to computing capabilities of Ignite. Okay, these select the best way to implement the threads responsible to run the working memory events. It's a continuous thread to run. We use the fire until halt. If you halt, we run again and again and again. If it occurs some error in Drools rules files, for example. So the microservices have the best performance using this approach.
I think that you mentioned that, but can you please repeat once again, what version of Ignite do you running now?
In production, we have 3 versions supported by now. We have microservices running in 2.7. Some clusters are implemented using 2.8, and some, I think it's 2-3 clusters are running 2.9.
And I see here experienced user, and they ask, any challenges you faced with Ignite cluster stability, brain split, for example? So how do you handle failures?
Well, about the Ignite cluster stability,
yeah. But actually, we face this kind of situation all the time.
Depends of microservice. Depends of microservice requirement, and we have many use. We have a failure handler which do not anything. Restart cluster depends. Some microservices uses integration using data store, cache store to bring all the data. If it crashes, it's over out only in memory. This data was lost if it crashes. So depends requirement. In this case, we're really restarting and so on. And the microservices continuous make the same thing, bring all the data they need when they need. So many of the approach.
And how?
As Nay said, okay, sorry.
No.
Yes.
Please proceed. Sorry.
Okay, as Nay said, we have more than 30 microservices in production environment. Each one, we have a set of setup configurations, okay, to run. Depends the requirement. I think we use Apache Ignite using most of capabilities of Apache Ignite, of the mix of the setups configuration or capabilities to run the resilience integrations with data.
So I think the next question is somewhere about the failures. How do you ensure that there are no events lost from the sources? Any kind of recon done?
Yeah, it's a very, very good question. When you implement using Kafka, for example, Kafka is responsible to log all the records about the events produced, okay? In this case, you use all the infrastructure and you trust in this infrastructure. All the events stay there. It's not the best approach when you talking about real time. Like I need to know the client or the customers clicked in this menu in this time. I have to take a look in this in real time and respond and offer service or marketing advertising, something like that. Okay, if we need in the service requirement some kind of some level of guarantees, we implement using the protocol. Using like I sent an event from interface. I need to know if the backend received that event. The backend received the event, put this in the Apache Ignite cache or table or whatever, and respond, "Ek, I receive your event, but I will try to process all the business process involved about this event. Only I said I save this event. Okay, we use this only when we need. If we use Kafka in this example, in 2 days, I can show the dashboard if you need. I hope you believe in me. We lead with about 40 terabytes in 2 days. We cannot put all these events in database, in the Kafka. You don't have infrastructure for that, okay? You have to decide what is the best information we have to put in the persistence layer. So it's a different approach, I know, but it's a complex event processing environment. It's very complex to deal with this high volume of events. Okay. Thank you for the question.
And good question with a good word, Spring. So is this microservices architecture being implemented by the way of a Java Spring Boot framework?
No. Java Spring Boot have approach to resolve 12 factors for build microservice, to develop microservice, okay? We have some integration using Spring frameworks and another layer of the application, integrating like using the approach or patterns of repositories, domain, and services, but our services are implemented using the CEP approach, not the request response approach, like Spring Boot implements. It's a little bit different of implement event-driven architecture. You can implement an application using request response oriented by event, okay? But not CEP applications, not CEP. Complex events is more a little bit more complex to deal, okay? We don't use Spring Boot framework.
Okay.
We use Apache Ignite service to run, etc.
Do you have multiple Ignite services per single node?
Sometimes depends of the requirements or the infrastructure resources we have. In the virtual assistants, for example, we have implementations which responds automatically like a chatbot. These implementations use one single node running about five microservices together to bring, but it's not necessarily. They are not coupled, okay? They are not coupled. They run inside only for the convenience. The infrastructure is limited. You can run many other ways because the event bus is the integration bus. All the microservices communicates with each other using this event bus.
New question in the chat. Can you scale Ignite service dynamically?
Yes, we have some implementations making something like that, but we have a dedicated infrastructure today. We could implement some virtual machines sometimes, but our environment is controlled. We can control the scale, this infrastructure. We don't need yet to scale automatically. We don't have infrastructure ad infinitum. We have a limited infrastructure, so we use what we have.
Thank you very much, guys. And I hope to see at least keynote submission from you to the Ignite Summit, our first community conference we are doing this May. And call for papers is still open. And guys, I will send the link along with the link to video and slides later. So you can join, and I hope to see you there. So thanks a lot.
Thank you, Ksenia. Thanks a lot.
Have a great day.
Thank you, everyone.
Or great evening, wherever you are joining us. And see you soon on our next meetup in April. We will speak about native persistent storage in Apache Ignite. See you. Bye-bye.
Bye-bye. Thank you.
Bye-bye. Thank you. Thank you, guys.